Okay, thank you very much for this opportunity to present on expected increase in the number of DNS queries this year. This is titled, but the contents of this presentation have nothing to do with movies. This is the outline of my talk. We expect an increase in the number of DNS queries this year. And the increase in the number of DNS queries may increase the DNS response time, which will have a serious impact on the quality of service to end users. And therefore, today I'll talk about an increase in the number of DNS queries from viewpoint of network operators, and would like to discuss how can decrease in the number of DNS queries. And this is today's focus. The DNS contains of many parts such as resolvers, cache servers, authoritative servers, and root servers, and so. Today I talk about focus on queries between user resolvers and DNS cache servers. We are expecting the increase in the number of DNS queries to be caused by two reasons. One reason is that IPv6 will be supported by operating systems. And the other cause is a domain name completion function. And this function is automatically performed by operating systems and applications. Now let's consider these reasons in more detail. The first cause is enabling IPv6 on operating systems such as Windows. As you know, almost all resources in the internet are handled by the domain name. And these domain names are translated into IP addresses by DNS. So domain names are, so that means DNS queries always originate from user actions. If IPv6 is enabled on an OS, query queries which ask for IPv6 addresses and send, in addition to A queries which ask for IPv4 addresses. Unix and Windows sends both A queries and query queries for every name resolution if IPv6 enabled. And the second cause is domain name completion. When a name resolution fails, operating systems and applications automatically resolve domains using domain prefix, suffix completion. For example, when the domain name resolution of host this is okay. This example, the host with no prefix or suffix, if fails, the domain name completion function automatically adds .com, .net, and the others. So Unix completes domains specified in the search field in resolve.conf, and Windows completes these specified in my computer or network interface configuration. Both operating systems use domains distributed by DHCP. Okay. In addition to domain name completion performed by the OS, some applications, like web browsers, try to resolve the completed domain name. When a name resolution fails, Mozilla adds the domain prefix www automatically and queries again. And Internet Explorer tries to search using MSN search, and then IE adds a domain suffix like .com, .net, .org, and .a, and makes numerous queries. Finally, if finished domain name completion, and the 404 not found error is returned to users. The domain name completion of such applications and repeatedly sent to the DNS resolver. This is convenient for users, but one user action may generate many DNS queries. Where combination of enabling IPv6 and domain name completion may increase the number of queries. The effect of combinations are different depending on the OS. In the case of FreeBSD, both A and query queries are made, and if the domain does not exist, domain name completion is performed. For example, consider the case of user query for noexistexample.com. Whether there is long example because there was already noexist.com domain. And the OS, both A and query queries, and if that domain does not exist, the domain name completion function adds a suffix such as .com or .net. And if the IPv4 address is resolved, stop after the second query. But however, in the case of Windows, the domain name completion behavior is different from the Unix operating systems. At first, the Windows OS tries query queries for all domain completions. Then, A queries for all domain completions are tried. We would like to show a typical case in the current internet. This domain, no IPv6other.com, has an IPv4 address, but not have IPv6 addresses. In this case, IPv6 enabled Windows tries query queries for all domain completions and then send A queries. So this is a very serious problem for DNS servers. And we examine the forthcoming new Windows. This slide is about the behavior of the next Windows Vista. 1. IPv6 enabled on Vista by default. And 2. We surveyed the behavior of IPv6 queries and domain name completion performed by Windows Vista and found that these behavior are the same as those explained above. And this is the important thing, I think. Windows Vista will be released this year. So this is an example of query from Vista. One user click has extended to IPv6 addresses, IPv4 addresses, and domain name completions by Windows Vista and Internet Explorer. In this case, one user click was extended to 12 DNS queries. And this is worst case. This is worst case. One user click was extended to 40 DNS queries. It's terrible. To consider these behaviors from the viewpoint of DNS cache servers, this is the number of DNS queries sent to a cache server from users of an ISP in Japan. Today, A queries comprise about 60% of the number of queries, and this is MX. MX queries comprise about 30% of total. Most of them are suspected of being sent by NetSky worms. Actually, query queries from users only comprise 5% or less today. When Windows Vista is put on market, consumers will use an OS that enables IPv6. we predict that the ratio of quad queries to A queries will increase depending on Vista market share. So depending on the behavior of Windows, DNS queries may increase by a factor of 2 or more. And this is conclusion. In conclusion, I talked about our expectation of increase in the number of DNS queries from users. This increase will be caused by IPv6 support and DNS domain name completion. Windows Vista, which has both of these functions, will be released this year. And depending on Windows, behavior of Windows, the number of DNS queries may increase by a factor of 2 or more. And let me move on to the discussion with you. We should prepare for this increase in our DNS cache servers. How can we avoid this increase? For example, network operators may reduce the increase in the number of queries by stopping DHCP domain name distribution to users, for example. When we think about the current status of IPv6 deployment in the market, we may need to suggest to Microsoft that the IPv4 record should be resolved before domain name completions are performed. That's all. Thank you.
Ed Lewis from New Star. Before we think about this as a problem, in terms of the number of queries out there, if you consider the alternative approaches to this, from the perspective of an applications designer, I'm going to look up a name. I'm not sure exactly which name I want to go to or what transport to use, A or quad A. So it's better for me just to ask everything at once, because I don't know, I'm not going to ask for one name and get back to NX domain, then ask for the next name, because that increases the latency I have in the application. So a lot of applications developers will want to ask everything they can at once. So in that case, you want to make the application developer a little smarter about what they ask for. They have to know ahead of time to ask or not ask, and not make it dependent on the query chain. Let's say the other alternative to this is to create a new way of asking DNS for information. Can I ask for many things in one query? That's been thought of and has never really been successful. And I'm not saying that we shouldn't try again, but we haven't been able to, within a DNS protocol, figure out how to ask more than one question at a time. So in terms of asking more things at one time in DNS, that's been hard. Getting applications to ask things more intelligently is going to be hard too. So it comes back to, is what you're seeing here going to be that much of a problem? Why not let the applications do all this post-processing of all the queries at one time and just let the DNS handle the load? I'm not saying that that's necessarily the right way to go, but that's kind of the three-part decision process here. I guess that's the first comment I have.
Thank you. Well, my understanding is right that you are saying that another kind of solution is packing all the information into one DNS packets.
Yeah.
Is that right?
Yeah. Basically, if you want the DNS to answer more than one, go back to the IETF and say we want you to do multiple queries in a packet.
Yeah.
Which is a lot of protocol work.
Okay. Yeah. Thank you very much. Thank you for your suggestion.
Joel Yegley, University of Oregon. From your projections, do you have a sense of how many of those new queries will actually have to fail over to TCP in order to be responded to?
Oh, you mean that the failover from V6 to V4?
Well, no. Failover from UDP DNS queries to TCP DNS queries, because the record that's returned is too big to fit in a packet. I mean, because obviously that, in terms of providing a resolver, that's a new, larger resource consumption right there. Right? Because I have to do a three-way handshake in order to return a response to a query.
Okay. Oh. Oh, I'm very sorry that I couldn't get the the question. So, you are asking about if Windows using the TCP connection instead of the UDP.
Yeah, I mean,
yeah.
So I make a DNS query, right, and I get a packet back from the DNS server that says it's too large. You're going to have to use TCP to make that query, right? That's a different kind of resource consumption on my resolver than if I can use UDP. The UDP query is obviously a lot faster. So I mean, one of the implications here is that if you have a lot of queries that return quad A records that are big enough that they don't fit in a single packet, then you've got a lot more TCP DNS traffic.
I'll try to answer the question. Actually, in this case, Joel, most of the other answers coming back is we don't have that information, so they wouldn't fail over. So it's just the number of UDP hits. Yeah, as long as you get next domain, you're fine. Yeah.
Tony Hayden. One of the things you didn't talk about in your sequence of events was what happens when the V6 record is returned, as valid. Does it stop the chain right there? You're focusing on the point of there aren't any V6 records and how long it takes to fail through, how many queries happen. What happens when the V6 answer does come back? Is the first part of the question. The second point is, your last item here about trying to flip the order and have the A records queried first. If you do that, we will never leave IPv4, because as soon as it resolves IPv4, the traffic will stay IPv4, and all of the traffic on the internet will stay IPv4, and people will perceive that that's the way they have to do their work. If you want to actually get off of IPv4, you have to resolve a V6 record first.
Oh yeah, you're saying that IPv4 asking is the first things to do?
No, I'm saying you can't do that last bullet item. If you do the last bullet item you're asking for, then the internet will never leave IPv4 because all the traffic will stay there. As soon as you get an answer back, you're going to use the V4 side to you're not going to keep asking for V6 records. Right? So you have to resolve V6 first.
Okay. Please discuss on the fly, please. I'm very sorry. Thank you.
Thank you.
Yeah.